All right, this is 10-1 of the Green Book. So step 1, we're going to break down 20 into prime factors. An easy way to do that is if I just break it down to any factors, 4 times 5. 5's a prime factor. I can break 4 down into 2 times 2. And then I'm going to break 24 down. So 2 times 2 is 4, times that 5. Those are all prime numbers. 24, we can think of like 4 times 6. 4 is made up of 2 times 2, and 6 is made up of 2 times 3, so you just list them all. Now, what we can do is we can cross-cancel fancy ones, a common factor of 1. Any number over itself equals 1. So do we see any fancy ones there? Ryan?
There's
two sets of 2s. So when I'm cross-canceling like that, I'm actually left with, when I do that, I'm left with 1 on the top and a 1 on the bottom. And I can do the same thing to the other set. I'm left with a 1 on top and a 1 on the bottom. And so then we just multiply the whole numerator. 1 times 1 times 5 is 5. And 1 times 1 times 2 times 3 is 6. Okay, questions? All right, so now, basically what we're talking about is how to reduce a fraction. This is one method. We're going to be doing this with fancier fractions. So if I have something with numbers and variables, just break it down to the prime numbers. Can 5 be broken down anymore? No, but how many A's are there up here? A times A times A. And how many B's?
2.
And then 35? 5 and 7. How many A's?
1.
And 3 B's. Now, what happens, what I don't like about this method is really that you're not going to be doing this every night, because what happens if you get like x to the 50th? Who wants to write out all those x's? Okay, so yeah, we can cross-cancel our matching pairs, take out a pair of 5s. I'm really left with 1. Notice my PowerPoint doesn't write the 1, but it's there. Okay, every time I'm cross-canceling, okay, and what's left in the numerator? Ryan?
A squared.
A squared over 7. Okay? 7b. Okay? Now, we can do the same thing without expanding it out. I just want you to know, on my PowerPoint may not be writing all those ones, but they're there. Okay? Don't tell me that 0 is left. Because if you end up cross-canceling everything, what's really left? 1. Okay, so when you're doing it in class, I think the easiest thing to do is numbers with numbers, variables with variables. Okay? What can I cross-cancel out of 5? What common factor can we divide out of 5 and 35? Preston.
5.
I can take out a 5. And so when I divide out of 5, what's left?
1 over 7.
1 here. And in the denominator, when I divide 35 by 5, what's left? 7. Okay? What's the greatest amount of A's we can take out of both numerator and denominator? Shaylin. I can take 1A out here, and I'm left with 1. I'm sorry, what am I left with? A to the second power. And I can take 1A here, and what's left? 1. What's the greatest amount of B's we can take out? Moreno? Or B squared. And what's left in the numerator? In the numerator? 1. And in the denominator? B. So now I multiply straight across, and what's left in the numerator? Over 7b. Questions? Is everybody remembering how we did that? These are what we call monomials. The numerator's a monomial, the bottom's a monomial. It's a term all tied together by multiplication, made up of variables and or numbers. All right. So that's how we're going to start doing this. I want you to try and do it on your own on number 1. Go. And you can try number 2, but just for sure do number 1. Pause the recording and do this. Okay, Shaylin, what am I doing?
Walking through it. Okay, so 6x squared and 10x.
Well, first, what am I dividing out?
Well, you're dividing out 2x.
Just let's start one piece at a time. I do not want you doing 3 things at a time. So what is it? Step 1?
Step 1,
Divide out what?
2x.
Numbers first, variables that are like 3 separate steps.
So divide out
2, and what's left in the numerator?
3,
3, and in the denominator? 5. If you're doing it like that, I want to see the slashing. Okay? Now x's. What am I dividing out?
divide out 1x,
And in the numerator, what's left?
x,
And in the denominator?
1.
Good. Now, last one, Amrit, what am I dividing out?
You're dividing out 3y.
A y. And what's left in the numerator?
5
Okay. And in the denominator? Good. And so my final answer is, Amrit?
3x, 3xy over.
Perfect. Questions? Okay, what are your thoughts about number 2? What do you think we do? Shaylin.
Well, I think you can cancel out the x's.
And then?
So then you'd be left with 1 and 1. And then you can cancel out a 2 out of 10 and 2. So, and then 5 in the numerator. So then you'd add 5 plus 5 and you get 10.
Agree?
Yeah.
No. Okay. Okay, this is the golden rule. The numerator is what we call a binomial. What you had over here when we were cross-canceling, we had monomial over monomial. Okay? As soon as you have a binomial, you may not cross-cancel a binomial unless you're cross-canceling the entire binomial. You may never take a piece of a binomial. Okay? So, step 1, the first thing you need to do is factor. Factor the numerator. What is in the numerator? What is it factored to? We're not taking out, we're factoring. What's the factored form going to be?
5 times the pi of x plus 2.
Okay, over x plus 2. Once I factor, now you will notice I am left with a binomial that is exactly the same. Now I may cross-cancel because the golden rule is you may only cross-cancel a binomial if it's exactly the same. So if this were x plus 2 over x plus 3, you can't just cross out the x's. It's like taking a piece of a body. You can't invite somebody to the movies and then half of their body goes to the movies. You just can't do it. You can't take half of a binomial out. If you're going to take it out, you have to take it, it has to look exactly the same. So when I'm seeing x is the same and 2 is the same, they're both positive, positive. The binomials are exactly the same, so I can cross-cancel. And now what is left? 5. Now, with Shaylin, I think you had the right answer, but you got it the wrong way, and you won't be able to do that in future problems. It was coincidental. Okay, questions here. So you must factor. Basically, that's going to be the golden rule. Factor the numerator, factor the denominator, and see what you can cross-cancel. Are there monomials to cross-cancel? Are there binomials to cross-cancel? Yes?
Let's say when you factor 5x plus 10, and then let's say it's 5x plus 15, you get x plus 3, and then in the denominator it's x plus 15.
There's nothing to reduce. It's like saying reduce 2/3.
Okay.
Can you reduce anymore?
No.
So,
Is that your final answer?
yeah.
Okay.
Because you're basically just reducing a fraction, simplifying it. Yeah.
Would you write, can't factor anymore, or would you just leave it?
Yeah. Can't factor anymore. But, I mean, the likelihood that they're going to give you something that you can't factor anything anymore. Because basically what we're going to do is we're going to learn how to reduce them. Then we're going to learn how to multiply 2 of these that are not equations. Once we learn how to multiply them, then we're going to learn how to divide them. Once we learn how to divide them, then we're going to learn how to add them with an unlike denominator. Then we're going to learn how to, with a like denominator. Then how to add them with an unlike denominator. Then we're going to set it equal to something. And you're going to actually solve these. Okay? And then we're going to go to word problems and put it to a real situation. So we're basically building you up for that end result. So let's take a look up here. With the plus sign, the binomial, it can't be simplified because there's no common factor between the binomial of this and 3. With this is a monomial. Remember, a monomial is tied together with variables and or numbers. And anytime it's multiplied with no plus sign in the middle, you can cross-cancel that factor out. Let's try it. If I take the same one, 3 plus 4 is what?
7.
Is there any common factor we can divide out? No, we got to leave it like that. The next one, if I substitute a 4 in, I can multiply it out, or I can even cross-cancel here. It doesn't matter. What is this equal to? 4, because I'm really dividing out that common factor of 3. So, with monomials versus a binomial, when you are cross-canceling the binomial, it has to look exactly the same. Okay? All right, so why don't you try these two? Let's try these two. What time are we out of here?
29.
Okay, good. Okay, let's try, why don't you guys try number 1? Remember, factor, factor, then cross-cancel. Pause the recording and see if you can do number 1 and 2. We are factoring the numerator to x plus 5. Now let's check your work. X plus 5, x minus 5, and the denominator?
I factored out 5 and got 5 times quantity x minus 5.
Good. This seems to be the hardest kind of factoring, this GCF factoring. I'm finding the most mistakes happening right there. All right, so now what would we do? What are we doing? How about Jake? Can we cross-cancel something?
Yeah, but
Just the
x minus 5.
x minus 5 and x minus 5. And so I'm left with this. Can I cross-cancel the 5s? No, because it's part of a binomial. So I can't get rid of, remember, a binomial is 2 terms, and we are done. Okay, what would we do here? Step 1. On number 2, Andrea.
Step 1 for the numerator, you're going to factor out a 3.
Uh, Keep
Yeah,
going.
And then you're left with x squared minus 9.
Good.
That's the difference in squares. You could do 3 times the quantity x plus 3 times the quantity x minus 3.
So hold on, let me write.
Yeah.
3 times x squared minus 9. I'm going to continue. I know that will become 3 times x plus 3 times x minus 3. Okay, and now I am dividing by?
You can see by the trinomial at the bottom. The 2 factors for 21 are 7 and 3, and since it's negative, it's 3 and negative 7.
So remember, we're just doing what multiplies to negative 21 and adds to negative 4. What did you say?
3 and negative 7.
So this becomes?
X plus 3 times the quantity x minus 3. X plus 7.
Minus 7.
Minus 7.
Okay, so I'm just following that over. I know it's a lot of writing, but you know what? It's much easier than word problems. So be thankful. Okay, now what? Teddy.
Now you're gonna cancel out. So you see that both the top and the bottom of the fraction have x plus 3. So you can cross that out. That becomes 1. So you're left with 3 times the quantity of x minus 3 over x minus 7.
Perfect. And are we done or do we keep going? Hello? Okay, so are we done or do we keep going?
Since we're simplifying, not factoring, I'm pretty sure that we would get 3x minus 9.
We don't need to. We just leave it. Don't take it that extra step Now, Teddy, you wouldn't be wrong. What he was going to do is just then multiply that back in. But it's easier for me to check in factored form. I want it this way. And you're just running the risk of making one more mistake. Yes?
And so if we got, like, in a problem, like, something, like, if we got 3x minus 9, do we have to factor it, or can we do that like that?
I would like it factored, but it is the same value, so it wouldn't be... It wouldn't... Basically, I need you to take out as much as you can. Factored form is the easiest to check and the least amount of mistakes for the teacher. Okay, so now let's move on. Let's move on to the challenging stuff. This is the part that... Okay. If this is a factor of 7, what would the opposite be? Yep.
-7?
Good. Next one. Everybody. Okay, next one. Okay, good. Or negative times the quantity of x plus 3, which equals, like you said, negative x minus 3. Okay, next. Y minus 8. Yes. Okay, so he said negative 1 times the quantity of y minus 8, or negative what? Negative y plus 8. Now, can we rewrite that with the positive first? What would it be? 8 minus y. Do you see how the opposite of this would be, look, from here to here, are you with me? With the positive first. So what would the opposite of this with the positive first be, Annabella?
3 minus 2x.
3 minus 2x. And what would the opposite of this be, Eric?
Negative x plus 5, or negative 6 plus 5x.
Okay, one more time. I said with the positive first.
5x.
Who can say this one? Okay, Henri.
5x minus 6.
5x minus 6. The entire thing opposite with the positive one first. Okay, next one. How about Giselle?
8 minus 2.
Perfect. You understand the idea? Okay. Now, how do I rewrite this as a product of negative 1 and the opposite? What times negative 1 would equal negative m? What's the opposite of negative m? Yes.
M.
So what would it look like?
It'd be negative 1 times negative m.
Negative 1 times negative...
Negative 1 times m.
Times the opposite, right. Negative 1 times the opposite of this equals this. Okay, what would I need to do for this one? Let's go, Luca.
Negative 1 times d.
Negative 1 times d. Would negative 1 times d equal positive d? What's the opposite of this? Look what it says, a product of 1 and its opposite.
Negative 1 times negative
Equals d, right. What would this be? Okay, Luca?
Negative 1 times the quantity of x plus 4 equals negative.
Stop. X plus 4. That's it. They're only asking for this. I didn't ask what it equaled. It should equal that. When you mental math it back, it should equal back. Okay? Let's try Preston, the next one.
3 minus 3 equals negative 1 times the quantity of 3 minus b.
3 minus b. Negative 1 times 3 minus b. What would this one be? Number 5. Eric.
Negative 1 times the quantity of negative 2x plus 5.
Can you rewrite it with a positive first?
Negative 1 times the quantity of positive 5 minus 2x.
Perfect. You don't need to say positive 5. Just say 5 minus 2x. Try it again. Go.
Negative 1 times the quantity of 1 minus x squared.
Perfect. Irene.
Negative 1 times the quantity of y minus 6.
Good. Number, and the last one, Miranda.
It would be negative 1 times the quantity 7k squared minus 3.
Perfect. Okay, now we're going to use that. Okay. Let's factor the numerator. What do we need to do, Jack, to factor the numerator? What does this become?
It's a perfect square.
No, it's not a perfect square.
Number
It's all up there on the board. It's not a perfect square. Somebody, Juan.
It's a difference of squares.
Okay, a difference of squares right there. That's different than a perfect square.
Sorry, I thought I said.
You said a perfect square.
I was
Okay.
thinking of difference of squares.
Okay, so Juan, how do I factor that?
It is the quantity of x plus 3 times the quantity of x minus 3.
Good. Over 3 minus x. Now, are there any binomials we can divide out? Any binomials we can divide out? Moreno?
X minus 3 and 3 minus x.
Can't divide it out like that now. Remember, they have to be exactly the same. They have to be exactly the same, so I can't do x minus 3 and 3 minus x. Because here, x is positive, and here, x is negative. And here, 3 is negative on the numerator, and 3 is positive in the denominator. So, Ethan, what might I be able to do?
You need to make 3 minus x the opposite and put the negative as a positive.
By factoring a negative 1. So if I factor a negative 1 there, they have to be exactly opposite, not just one of them opposite. Okay, if I factor a negative 1, what does this become? Negative 1 times
X minus 3.
And now, what can we do? Moreno?
Now we can factor the negative 1.
We've already factored the negative 1. Now what?
Cancel out the x minus 3.
X minus 3. And so we are left with x plus 3 over negative 1. I can take the negative 1 in the denominator, in the numerator, or I can multiply it in, right? So you can stop here, or keep going. I kind of prefer here. Okay, questions? Now, like I said, I kind of prefer it here. Yes.
Why do you multiply only the denominator by negative 1? Because don't you have to do it to both sides?
No. Because isn't this? No. It's both sides of an equation, hun. We're in an expression. When I multiply this whole thing out, is this equivalent to this?
Yes. Oh, so you're just changing the.
I'm just renaming it so I can cross cancel that part of it.
Okay, that makes sense. Yeah.
Okay? So it doesn't have to be, I don't have to do what I do to the denominator, I do to the numerator. It's both sides of the equation when you do that. All right, so you guys try number 2, go. Pause the recording. All right, now let's check our work. So the numerator factors 2. Remember, we do x marks the spot, if you forget, n plus 6, n minus 6 times n minus 5. N minus 6 times x plus n minus, one more time, n minus 6 times n plus 5. There we go, sorry. And what about the denominator? What is that factoring to? Yes?
6 plus n, 6 minus n.
6 plus n, 6 minus n, good. And we end up with, can we cross cancel anything? So, Henri, what can I do?
You have to add a negative. You have to multiply the denominator.
We're not multiplying, we're going to say factor. Factor a negative out of one of the binomials. Now, it doesn't have to be in the denominator. I could have done it up here. Okay? We are noticing n is positive, negative, negative, positive. So they're exact opposites. So those are the two, one of the two. One of those two, not both. Which one did you do it to? Okay, so factor out that negative 1 and it becomes what? Yeah, and I can put that negative 1 in the middle. Here, it doesn't matter. Do you understand? You'll see I put it here for this one. Are you guys clear on that? And now I can cross cancel my n minus 6's, and we are left with n plus 5 over negative 1 times n plus 6. And we just leave it like that. No more fancy business, yes.
So when we do the -1, it's not to both of them, it's only to one.
Just to one binomial, yeah. Unless both binomials, you can do that up top twice, too.
Okay.
All right, so now, just a reminder, now there's a couple different things we're gonna have. You're gonna have all different kinds of factoring. Remember, if you're factoring, go off to the side and do this. Don't make me search for where the problem starts. This is really two problems. So over here, remember, we're gonna have to do the lead coefficient factoring, where I multiply both of those and I get -6, and what adds to 1? It's 3 and -2. And so remember, we're using the first one, 2x squared. We use the last one, -3. I do -2x plus 3x. And remember this, guys? I'm doing a quick review. Factor out the 2x, and I'm left with x minus 1. Factor out a 3, a plus 3, I'm left with x minus 1. 2x plus 3 times x minus 1. Are you guys remembering how to do this? Yes?
Yeah.
So remember, we're doing that. Do that stuff off to the side. Okay? And so now I've got 2x plus 3 over x minus 1. On the bottom, how do I factor that? Yes.
1 plus x and 1 minus x.
1 plus x, 1 plus x, and 1 minus x. And now I'm going to have to go again. Okay, I'm going to have to do it again. What are we going to do, finally? Somebody? Okay, Ryan?
You can multiply.
We're not multiplying.
Factor.
Factor.
You can factor out the bottom by -1.
I'm going to factor this binomial on the bottom or this one. It doesn't matter. And let's see, look at my numerator. This time they did it in the numerator to this one right here. And they made it become opposite. Are you noticing that? They're really affecting this binomial. This one here and this one become opposite because they're putting the -1 there. Okay, and now I can cross cancel, and we're left with this. Now, 2x cubed minus 200x. Don't forget your GCF factoring. Let's just look at what happens. You're not going to have time to write this all down because I need to show you domain. 2x, I can factor out the GCF. I still got to factor more. X plus 10, x minus 10. Now, I've got to make one of these become, I've got to not only break this down, but I've got to factor out a -1. Notice what they do. They just make that negative there in the denominator, the 10 negative at the in the denominator, and that makes it go opposite. Are you understanding? Now I can cross cancel. Now, cross canceling monomials with monomials, binomials with binomials. So divide out a common factor of 2 and a common factor of x. And our binomial x minus 10, and we are left with x plus 10 over -5. Okay, are we understanding? Yes? No? Thumbs. Okay, one more thing. I need you to stay. Domain. Domain is what is x allowed to be? The values of x. So in this case, this is a fraction. What's the golden rule for fractions? One of the 10, what? Thou shalt not divide by 0. So you're going to do the same thing you did before, but you're going to do one more thing here. When I say thou shalt not divide by 0, the first thing you got to do is factor. We're going to simplify like we did before, and in the factored form is where we can figure out what the domain is allowed to be. I take both my factors. What would make this become a 0? Hello, can I call you back? Who is this? Yes, yes. Okay. Okay. Jake, that was for you. Okay, let's finish this. Okay, what makes the x become a 0? If it's a 0, right? Really just using your zero product property here. And what would make the x minus 4 become a 0? Because these are two factors. A number times a number. If one of those numbers is equal to 0, it will make the whole denominator 0. So what would make this, if this is a 0, and what number would make this become a 0? 4. So, in terms of the domain, we're going to say x is any real number except x cannot equal 0 and x cannot equal 4. But now we're going to simplify. The domain really has nothing to do with simplifying. We're simplifying, and I'm left with this. But it's saying simplify and state the domain for x. X is such that x is an element of the reals, but x cannot equal any real number, can equal 0 or 4. Do you understand? So the point where we determine the domain is in the factored form before you cross-cancel things. You cannot do it in the beginning because we don't know what factors make up the denominator. You can't do it in the end because you've already gotten rid of the x. Okay? So we're going to factor, right? This is the point I determine my domain. What would make this equal a 0? If x equaled what? Right here for this factor. 0. And here for this factor? 3. So x is such that x is an element of the reals. X cannot equal 0. And x cannot equal what? 3. 3 for this one. This one would be 3. Do you understand that, Jack?
Yes.
Okay, and then we cross-cancel. That's the simplified. There's the domain. Are you guys understanding that? One more. Factor. What would make a 0 here? Negative 2. So it's any real number except x cannot, and then we can cross-cancel. That's my simplified answer, and there is the domains.